Find the maximum value of n such that 157 factorial is perfectly divisible by 12 to the power n. In other words, they are trying to ask how many number of 12s are available in 157 factorial. The words are changed in the question, but the question is as simple as find the number of 12s in 157 factorial. But we need to take care because 12 is not a prime number, because in case of a prime number, let's say if the question would have been find the number of, let's say, 7s in case of 157 factorial. Now I know that in order to get a 7, it should only be a multiple of 7, like it can be 7 times 1, 7 times 2, 7 times 3. It should be a multiple of 7, then only I can get different number of 7s in 157 factorial. But the same case is not at all true for composite numbers, because if, let's say, if I have a 3 and a 4, 3 times 4 will give me 12. Or let's say if I have a 2 and a 6, it will again give me a 12. So we cannot apply the same logic for composite numbers. So what's the method now? What should we do now? Let's prime factorize 12 first of all. So when I'll prime factorize 12, this means this is equal to 4 times 3, 4 3s are 12, which will again give me 2 times 2 times 3, that is 2 square times 3. Now if I want a 12, I have broken it down into its basic prime numbers from which this 12 is formed, which means that in order to get a 12, I need 2 2s and 1 3, then only I can get a 12. And 2 and 3 are prime numbers. So in this case, in case of 157 factorial, if we can find the pairs of 2 squares and 3 available, then we can easily find the number of 12s available in 157 factorial. Now let's see how we can do that. Let's start with the easier one. Let's say that we are trying to find the number of 3's in 157 factorial. So we'll start with 157 divided by 3. We'll take the greatest integer of this, plus 157 upon 3 square. We'll take the greatest integer here, plus 157 upon 3 cube, plus 157 upon 3 to the power 4. This process will be continued till we'll have 0 as our greatest integer. Then 157 upon 3 to the power 5, then again 157 upon 3 to the power 6, and let's see what value do we get till here. So 157 upon 3, so this will be equal to this. Let's divide 157 with a 3, so 3 5s are 15, I'll have 7 here, 3 2s are 6, 1 as the remainder. So this will be 52 point something. The greatest integer will be the integer slightly below this, and the integer just below this, lesser than this, and an integral value. So this will be 52, because this is 52 point something. Plus now we have to divide 157 with 3 square. So let's do that. So 157 divided by 9. So 9 1s are 9. I'll have 6 here and 7. 9 7s are 63. I'll have 4 as a remainder. So this will be 17 point something. The greatest integer of that will be 17. Plus again now I have 157 which I need to divide with 3 cube, that is 27. 157 divided by 27. Now if I'll multiply 27 with, let's say, 5. So what I'll have here, 7 5s are 35, 3, 5, 5 2s are 10, and 3 13, 135 I'll have here. On subtracting, I'll get 2 and 2, 22. So this will again be 5 point something, and the greatest integer will come out to be 5. Plus now let us divide 157 with 3 to the power 4, that is 81. 157 divided by 81. So this I can take it as, if I'll take 2, this will be 162. So I cannot take that. So this value will be equal to 1 point something, and the greatest integer will be 1 itself. If I'll reach this 3 to the power 5 is greater than 157. So this greatest integer will be 0, because this value will be some 0 point something, and the greatest integer of this value will be 0. Similarly for this, so we don't want to actually continue further. We'll end our process up to here. So this total is equal to 52 plus 17 plus 5 plus 1 is 6. 17 plus 6 is 23, and 23 plus 52 will give me 5 and 7, 75. So this 157 factorial will contain 75 number of 3's. Now we want number of 2 squares. Just take care that we don't want the number of 2's. We want 2 squares. So what we can do here, let's do one thing. Let's count the number of 2's. Let's count the number of 2's first of all. 157, let me use some different color. 157 divided by 2, I'll take the greatest integer of this, then 157 upon 2 square, greatest integer of this, then 157 upon 2 cube, I'll take the greatest integer, and this process will continue till I have 0 as my greatest integer. 157 upon 2 to the power 5, I'll get a lot of values here. 157 upon 2 to the power 6. Let me do this here, then we'll continue further. So this value will be equal to 157 by 2 is equal to 2 7s are 14, 1 7, 2 8s are 16.5. 78.5. So the greatest integer will be 78. Plus, now let us divide 157 with a 4. 157 with a 4. The value will be 4 3s are 12, 3 will come down, 7, 4 9s are 36, and this will be 1. So this will be 39 point something. So the greatest integer will be 39. Now let us divide 157 with a 8. 157 with a 8. So 8 1s are 8. I'll get 7 here and 7 here. 8 9s are 72. I'll get 5 as remainder. So this will be 19 point something, and the greatest integer of this will be 19. Now I have here 157 upon 2 to the power 4, that is 16. So let me do that. So 157 divided by 16. So I'll take 9 because 16 tens are 160. So this will be 9 point something. Greatest integer will become 9. Now let me divide 157 with 2 to the power 5, that is 32. So this will be equal to, if I'll take 5, 2 5s are 10 and 60, 160. So I cannot take 5. Let me take 4. 4 2s are 8 and 4 3s are 12, 128. When I'll subtract them, I'll have 9, 2, 29. So this will be 4 point something, which I'll take it as 4 here. The greatest integer will be 4. Now let us move on to 32. Let us divide 157 with 2 to the power 6, that is 64. So this will give me 64. 2s will be 128. 8 and 128. So this will be 2 point something. The greatest integer will become 2. And finally let me move down to 157 divided by 2 to the power 7 now. So this will become 64 times 2, that is 128. 128 I'll take 1 time. So this will be 1 point something basically, and this will be equal to 1. And after this I think the value will be greater than 157. So I'll get 0 as my greatest integers. So this total will give me number of 2's available. So first of all, let us add them. So 2 plus 1 is 3, 4 and 3 7, 9 and 7 is 16, 16 and 19, 26, 36 and 35, 35 and 39 will be equal to 9 and 5 is 14 and 74, 74 and 78 will be equal to 8 and 4, 12 and 152 here. So we'll have 152 152 twos. So now if I'll ask how many 2 squares will be available if I have 152 2's, this means number of 2 squares is half of 152, that is 76. 76 number of 2 squares I will have here, and the number of 3's that I got is 75. So I'll take the lesser value because I need to form a pair of 2 square and 3. So that is why we'll have total 2 squares and 3 combinations of total 75 pairs, and therefore the number of 12's available will be 75.